Okay, so you're cramming the night before exams, and you seriously are cooked if you don't do enough past papers. Well, I got you, fam. I'm gonna take you through the February-March 2026 paper 12 of AdMaths in a somewhat entertaining way. There are chapters in the video player below. These are the questions that I'm facing today, and damn, this question made me regret my life choices. Alright, enough yapping. Enjoy the video. What is going on, everybody? Today we're going to do the February-March 2026 paper of AdMaths. This is gonna be paper 1, so this is a non-calculator paper. So let's get right into it. Okay, let's zoom into the first question. What do we have here? A polynomial p is given by 4x cubed plus 8x squared minus x minus 2. Show that x plus 2 is a factor of p of x. For x plus 2 to be a factor of p of x, when we divide p of x with x plus 2, our remainder will be 0. If our remainder is 0, x plus 2 is a factor of p of x. So the method to do this is, first we have to find x. Now x is minus 2. Now we have to substitute x equal to minus 2 inside the x's over here. And if p of x equals 0, then x plus 2 is a factor of p of x. So let's do it. Okay, so we have substituted x equal to minus 2 in here, here, and here. Now let's calculate it. Plus 2 and minus 2 cancel, so this is 0. And 4 times minus 8 is minus 32, and 8 times 4 is positive 32, so this gives 0. As the answer is 0, that means x plus 2 is a factor of p of x. So we can just leave this and go to the next question. Solve the equation p of x is equal to 0. Let's substitute the algebraic expression of p of x here. Now, how do we solve this thing? We solve this thing by first factorizing it. And now, how can we factorize this? We can factorize this by using synthetic division, because we have this as a factor. If we have one factor, we can find out the other two factors by synthetic division. This entire p of x has 3 solutions because the maximum power of x is 3. So let's do synthetic division. At first we put the coefficients of p of x. First x cubed, then x squared, then x, and then the x independent term. Then we draw a big L shape, and then we put the value of x, that is minus 2. Now let's do synthetic division. First, the 4 comes over here. Then we multiply 4 times minus 2, that is minus 8. Then we add 8 plus minus 8 is 0. Then 0 times minus 2 is 0. Then we add minus 1 and 0. Then we get minus 1. We multiply minus 1 times minus 2. We get positive 2. We add minus 2 and plus 2. That gives us 0. If we have a 0 over here, that means minus 2 is a factor of p of x. And yes, we just proved that it is a factor of p of x. So the other factor is 4x squared plus 0x minus 1. Now we don't have to write 0x, so I'm going to eliminate it. So this is our other factor. Now let's rewrite p of x. Now this is equal to 0. We know by a general rule that when product of some factors equal to 0, any of them can be 0. So the possible answers are x plus 2 is equal to 0, or x is equal to minus 2, that is the first solution, or 4x squared minus 1 is equal to 0, or 4x squared is equal to 1, or x squared is equal to 1 over 4, or x is equal to plus or minus 1 over 2. Wait, no, not root. Plus or minus 1 over 2. So our solutions are x equals minus 2, x equals minus 1 over 2, and x equals 1 over 2. And that is our final answer. Next question, please. On the axis below, sketch the graph of an absolute function. Let's do some rough work. In our head, we must factorize this first. We have to think of two numbers that multiply to minus 3 and add to minus 2. Yes, we got it. It is minus 3 and positive 1. Now let's take common. Now we want to find the x-intercepts. The x-intercepts are here and here. the y value is 0. That means this equals 0, right? So x squared minus 2x minus 3 is equal to 0, or x minus 3 times x plus 2 is equal to 0, or x equal to 3 and x equal to minus 2. These are our x-intercepts. Here is minus 2. Here is 3. Then we have to find the y-intercept. Our y-intercept is somewhere over here. And at our y-intercept, the x value is 0. So we can just directly substitute 0 in places of x and see what we get. So our y-intercept shows 3. So it is gonna be over here somewhere. Yep. And minus 3. Now, why did I give minus 3 over here? It's because I'm gonna show you in just a moment. This was supposed to be our actual curve, right? But this is an absolute value sign, which means any y value that is negative should be reflected upwards. So the correct curve will be this. Now for some beautification purposes, you can do a dotted line over here, just to show the examiner that it goes from there to there and it is reflected upwards. Okay, so this is how you draw an absolute value curve. Next question. The function g is defined by this for all real values of x. Find the expression for g inverse. Now, listen up closely. We know that any expression can be equated to y. So, y equals g of x, or y equals, we can always write this. Now, to find the inverse function, what we will do is we will interchange y for x. Now from here we will make y the subject, and that would be our expression for g inverse of x. First we take minus 1 over on the other side of the equal sign. We take everything over here. Then we divide both sides by 4. Now when we want to make a variable subject and that variable is on the exponent of a base like this, we will take the natural logarithm. It solves all of our problems, even your relationship problems. Now by the formula that I'm showing on the screen, we can directly pull the exponent out of here and into the normal region. Now what do I mean by the normal region? That is, now we have ln e, and ln e is just 1, so we can completely ignore it. Then we take this minus 2 and take it on the other side of the equal sign. And as I said, this is our expression for g inverse of x. Let's write this beautifully. Okay, next question. This was quite easy. Oh, whoa, what do we have here? So we have to be a little cheeky here. The particle moves with a constant acceleration. Constant. That means the velocity will increase at a constant rate. It will be a straight line from 0. Now, we know the base of the triangle that we are going to make. We know that the base is going to be 4 because when t equal to 4, the s is 6. Now, how do we find s? S is the area of the triangle. That means we know for a fact that area under the velocity time graph is the displacement of the particle. So the area under the graph is the total displacement of the particle. So we have the area as 6 meters, we have the base as 4 seconds, and we know that this is gonna be a right angle triangle. We have the base, we have the area, now we want to know the height. Now how are these connected? These are connected by, of course, this formula, and we substitute the values. The area is 6, then half, then 4, and we want to find the h. How tall is going to be our triangle? This is simple algebra. H equals 3 units, so this is 3. We put a dot over here. This is going to be our height, and this is going to be our base. So the graph will be... Now we want to check if our graph is correct or not. We will check it by looking at the conditions set in the question. When t equals 4, the distance traveled is 6. So when time is equal to 4, the area under the curve is going to be 6. So let's calculate the area under the curve when time is equal to 4. This is 4, this is 3. So half BH is equal to 6 meters, right? So our math is correct. And hence find the acceleration. We know that the acceleration is the gradient of a velocity time graph. So let's calculate the gradient of it. Wait, at first let me write it. Now, this is a point 4, 3, and this is a point 0, 0. Can we calculate the gradient of this line? Obviously we can. The gradient formula is this, and then we substitute the values. 3 over 4. This is our acceleration. Alright, next question. Whoa, we have an arithmetic progression over here. The common distance d is minus 2. The sum of the first 4 terms is equal to the sum of the first 10 terms. Wait, what? That is kinda interesting. Okay, let's see how it goes. Now, what do we know about the sum of an arithmetic progression? That is, now when n is equal to 4, the sum is the sum of the first 4 terms. When n is equal to 10, this sum is the sum of the first 10 terms. So let's put the values. It says that the sum of the first 4 terms is equal to the sum of the first 10 terms. This is the sum of the first 4 terms, and this is the sum of the first 10 terms. I just substituted the value of d over here so we don't have to write too much. And let's solve this. Then we distribute 2 over on these terms and distribute 5 over on these terms. Wait, what is 18 times 5? Okay, got it, it's 90. That was a bit of a aura loss over there, but we'll ignore it, please. Thank you. Is 13. And that is our final answer. Okay, next question. A curve is such that y is equal to this. P and Q are stationary points on the curve. Find dy dx and the exact length of the line PQ. Okay, this is an interesting and a hard one. So, let's find dy dx first. This is our equation. Now, we will consider this as u and this as v. Now, how do we differentiate a fraction like this? Yes, by using the quotient rule that I'm currently showing on the screen, and let's copy it. P square. Okay, now let's substitute the values. Okay, now for my mental well-being, I'm going to simplify this a bit, not much. So we're going to distribute 2x over on these terms. This minus and this minus completely cancel each other out, so then we simplify this normally. Okay, so this is our dy dx. Now it is given that P and Q are the stationary points of the curve. Let's write this step by step, shall we? Our step 1 was to find dy dx. We have already done it. Now our step 2 will be to equate dy dx to 0. Why? Because P and Q are stationary points on the curve, and at the stationary points the dy dx value is always 0. And after this we will find the x values of P and Q. If we get the x values of P and Q, we will get the y values of P and Q by substituting those x values over here and here. And then our final step would be to calculate the exact distance between P and Q by using the formula that I'm showing on the screen. This one was our step 1, and now we are going to proceed to step 2. That is equating this to 0. This thing goes to there and it disappears because it is getting multiplied with 0. So we are going to multiply everything over here with -1, so this thing gets out of the equation. Okay, after eliminating minus x squared, we can factorize this easily, comfortably. Okay, that was quick factorization for you. That means x minus 4 is equal to 0, or x is equal to 4, and x minus 2 is equal to 0, and x is equal to 2. So we can name this like anything. I'm going to name this as p, and I'm going to name this as q. So the x value of p is 2, the x value of q is 4. Now we have found the x values of p and q. Now we will find the y value of p and q. We will substitute the value of x over there. Let's simplify. Minus 4, and at x is equal to 4, the y is equal to, so our coordinates are 2 comma minus 4 and 4 comma minus 8. Now let's find the distance between these 2 points by using this formula. We will subtract q from p. So p minus q, this is for the x, and p minus q, this is for the y. And that is our final answer. Thank you. Okay, next question. Oh, so easy. Wait, what is that? Okay, let's ignore that for now. Okay, this is pretty easy. This is an absolute value, so this equation can be split into 2 parts. Wait, not green, this should be blue. The first part will give us 3x plus 2 is equal to 7, and the second part will give us 3x plus 2 is equal to minus 7. Why this minus comes? Because we have an absolute value sign over here, and when we have absolute value sign, this thing can both be plus and minus. So this can be 3x plus 2 is equal to 7, or this can be minus 3x minus 2 is equal to 7. Now what I did is I separated minus 1 from there and pulled it over here, so thus we got this, and this is exactly this. So let's erase all of this and proceed. Let's do some speed math here. 3x is equal to 7 minus 2, that is 5, or x is equal to 5 over 3. And here 3x is equal to minus 7 minus 2, that is minus 9, or x is equal to minus 3. So our answers are, and okay, next question please. Oh no, what is this? Okay, so the way that I like to solve these equations is by squaring both sides. Now why do we square both sides? Because when we square minus and minus, we always get positive, right? So when we square this, we can get rid of the negative stuff that we don't have to deal with. Bro, trust me, this works most of the time. We square both sides and then we simplify by using the formula that I'm showing on the screen right now. Then we take everything on the left side of the equal sign. 4 minus 1 is 3, and minus 16 minus 2 is minus 18x, and positive 16 minus 1 is plus 15. Now let's take 3 common from all of these and write. So let's just get rid of this by bringing this over there and making it disappear like boom. And then we all know how to solve this thing, right? So let's get right into it. So our critical values are x equal to 5 and x equal to 1. So now let's draw the curve that we are gonna get over there. This is a smiley face, and this value is 1 and this value is 5. Now it is written greater than 0. When is our curve greater than 0? It is greater than 0 when it is on the left side of minus 1, and it is greater than 0 when it is on the right side of positive 5. Wait, that is not minus 1, that is positive 1. Okay, so when x is on the left side of minus 1, that is x is smaller than minus 1 because everything on the left of 1 is smaller than 1. Why am I saying minus a lot? Oh my god. And when x is on the right side of 5, because when x is greater than 5, the y value is greater than 0. So this is our final answer. Please get this out of my face. Whoa, what is this? This looks scary. Anyways, the variables x and y are related by this. Use calculus to find the approximate change in y when x increases from 4 to 4 plus h, when h is small like your brain. Okay, so now let's find the approximate change. we know that dy over dx is almost approximately equal to del y over del x. That is a nice del over there, but anyways. So this is the formula that we will always keep in mind when we are doing an approximate change math like this. So let's find our dy dx first. I'm gonna highlight it in orange. Now we want to write the root x as an exponent, and root over anything is to the power half by using the formula that I'm showing on the screen. Now I have just replaced the root over here with an exponent of half. Now this is on the denominator, so we can bring this up by switching the exponent to a negative exponent. That is done by just like this, and then we are going to differentiate this. The coefficient remains like it is, the exponent becomes the coefficient, and we decrease 1 from half and we get minus 0.5, that is minus half, and the exponent here turns into a coefficient, and we decrease 1 from minus 0.5 and we get minus 1.5, that is minus 3 over 2. Okay, let's simplify. Now that is our dy dx. Now this thing is true. Then we substitute dy dx for this equation. Now we have to keep in mind that this is our approximate change in y and this is our approximate change in x. What is our approximate change in x? Our approximate change in x is h. So we can directly replace del x with h. Then what was our 4? Our 4 was this, and then it became this, right? So we only take the previous value of x, okay? So our x over here is going to be 4. So now we have to simplify this. This is 11 over 16. Okay, so after simplification, we are supposed to find del y. So we isolate del y by multiplying h over there. Now del y equals 11h over 16, and that is our final answer. So guys, this formula is always to be remembered when you are doing an approximate change math. Okay, thank you. A curve has equation this. Okay, now find dy dx. What is our y? Our y is x e 2x plus 1. Now I'm gonna consider this as u and I'm gonna consider this as v. So our y equals to u times v. Now how do we differentiate a product like this? Yes, we use the product rule, and we do this by the coefficient of 2x comes over here, and then we write x over here. So our equation is, now we have e2x plus 1 over here and here, so I'm gonna take that as common. How clean does it look, man, very nice. Okay, what do we have here? The line L is a tangent to the curve at the point where x equals half. Find the exact coordinates of the 2 points where L meets the axis. So our curve, suppose it looks like this, and this is our graph. The line L is a tangent at point x equals half. So we draw a tangent over here, find the exact coordinates of the points where L meets the axis. So suppose it continues over here, and here we have the axis intersects. Now suppose we have a graph over here like this. What does it say? The line L is a tangent to the curve at the point where x equals half. So where x equals half, we draw a tangent. We draw a tangent like this. So find the exact coordinates of the 2 points where the tangent meets the axis. We want to find this point and this point. Now for a quick disclaimer, this is not how this curve looks. So yeah. Anyways, you know what we're talking about. Now we want to find the gradient of the tangent at the point x equals half. Now how do you find the gradient? By using this equation. The dy dx always gives the gradient of tangent. Now we want to substitute x is equal to half, so that is e squared times 2, and that is 2e squared. Now we have to find the equation of the tangent. We already know the x coordinate of the tangent. Now what about the y coordinate? The y coordinate can be found by substituting x over there and there. Y is e squared over 2. Now the equation of a standard straight line is, now we substitute the values. Our y1 is e squared over 2 minus yn. The gradient is 2e squared, and our x1 is half and minus x. Now we make y the subject. Okay, so this is our equation of tangent, and we want to find where this tangent meets the axis. Now our axis, now if we draw our axis like this, here the y is equal to 0. So to find the x-intercept, we have to set the y equals 0. Now we find the value of x from here. Our x is equal to 1 over 4, and for the y-intercept, x is equal to 0. So when x is equal to 0, this term becomes 0, and we are only left with this term. So our y equals minus e squared over 2. Now our answers are going to be, and that is our final answer. Whew, this was a good one. I like doing this math. Whoa, use your answer to 8a to find this. Okay, now I really love this kind of questions because there is a lot of room for learning over here. Now, let's copy the answer from our 8a. Okay, so now we have this, right? We want to distribute this over here, so this is an expanded form. Now we want to integrate x e to the x plus 1. We have to find in this equation where is x e to the x plus 1. Firstly, it is over here, and then it is over here. Now can we integrate this? No, I don't think so. But can we integrate this? Yes, because when we remove the d dx function from here, over on the other side of the equal sign, it turns into an integral over here and over here, right? So if this is an integral, essentially we have got our desired thing. Right, so I like this kind of questions because these are very imaginative like this. And let me clear this mess. So what I meant before is that when we remove d dx function from the left side and invert it on the right side, we are going to get an integration like this. Now can we integrate this? Yes, very easily. This is easily integratable. This, and then we just divide the coefficient of 2x, that is 2, and don't forget the plus c over here. Then guys, did you know that we can pull the coefficient out of this integration thing and pull it over on the outside of integration, just like this? Now, do you guys see what I'm seeing? If we isolate this in this equation, we are going to get our final answer. First, we take everything of here over on the other side of the equal sign. Now this plus c stays plus c because c can be anything, both positive and negative. If this c is positive, it will be plus. If this is negative, it will be minus. You don't know what the value of c is. It can be anything, so I'm just gonna leave plus over here. And then we divide both sides by 2, so this 2 cancels. And again, when we divide plus c over 2, this thing is another constant. So this is going to be another constant. And this is our final answer. Very, very nice. This question was so satisfying to do. Okay, vectors. What do we have here? Time is in seconds, distances are in meters, okay? At time p equals 0, the particle. So this is our velocity vector. At the same time, the particle b starts from the point with position vector this. So that is our starting position, moves with a velocity of 4, minus 2. Write down the position vector of b at time t. Now, guys, zoom in. Let me teach you a formula. S equals u plus vt. That means our final destination is going to be our initial destination plus our moved distance. We know that v is equal to distance over time, so our moved distance is going to be vt, and that moved distance is this. So essentially, this equation states that the position vector of a particle is the starting position plus the moved displacement. So let's insert the values. we add the top row and we add the bottom row. So this is our final answer. This is the position vector of B at time t. Determine whether or not the particles collide. Now, for the particles to collide, their position vector has to be same at the same time, which means if we have A here and if we have B here, when it is moving, and at a certain point, suppose TC, collision, this is the point, and B is moving, at TC, at the same time they collide. And when they collide, their position vectors are the same. So this is how they collide. And here T is equal to T collision. Now for everything to make sense over here, we have to first find the position vector of A. Then we have to equate the position vectors. Now guys, we have to find T at which they collide. If the top row gives a certain value of t, like suppose 5 seconds, and the bottom row gives another value of t, suppose t equal to 4, this does not make sense. What do I mean by that? Let me show you. Let's do the step 1 first. Now this is our position vector of particle A. Now let's equate it. Now we have two equations over here. The first equation is the top row and the second equation is the bottom row. If these equations give the same value of t, then they collide. If these two equations give different values of t, then they don't collide. Okay, we have got our first value of t. Oh, we have got our second value of t, which means these particles do not collide. Now how do we write this? We will write this by... This means that A arrived at that position at 1.5 seconds and B arrived at that position at 1.33 seconds. That means B arrived earlier at that position and A arrived later at that position, meaning they do not collide. If they collided, the time would be same for those particles. So that is our final answer. Oh my god, what is that, bro? Okay, let's try to solve this thing. Oh my god, what? The point Q is with the position vector this. Point R is this. Point S is AB, where AB are integers. Okay, it is given that S lies on the straight line. Okay, now let's draw a graph. This is our origin, that is O, and point Q is 3 units to the right and 2 units upwards, that is point Q. Point R is 1 unit to the left and 4 units upwards. Okay, so that is our point R, and S lies on the straight line of QR. So in this QR line, S lies somewhere here. Okay, it is also given that the length of RS is root 5. Now find the possible values of A and B. So our plan first is going to be find the vector QR, and then wait, let me think, this question is kind of hard. Okay, I got it. Then we have to find RS in terms of A and B. And then we use this because, yeah, I think this is important. Yeah, we connect this in terms of A and B. Now, what do I mean by that? Let me show you. But first, let's find QR. OQ plus QR is equal to OR, right? So let's substitute the values. Okay, so QR is minus 4i plus 2j. So basically we have to go 4 units leftwards and 2 units upwards from Q. Now let's find RS. We know that OR plus RS is equal to OS. We already have OS over here, so let's substitute the values anyways. So our RS is... Oh wait guys, I just realized this. We know that, wait, let me color code this. We know that R and Q create a straight line, right? And we also know that R and S also create a straight line, right? Now the gradient of this and the gradient of this must be the same because RS is a part of the same straight line. Oh my god, maybe we have just cracked the code. Let's use it. Forget this step 3. We are gonna make our own steps over here. Gradient of RQ is the y value divided by the x value. And the gradient of RS is going to be b minus 4 is over a plus 1. So the gradient are supposed to be the same. So let's equate them. Let's cross multiply. Oh, I forgot to mention that because there is a minus over here, the terms shift sides. That is one equation. There are two variables, so we need another equation. And oh boy, we can get another equation from here. Now the length of a vector is calculated by the x shift square and the y shift square, and we take the root, and that is the length of a vector. Now the x is here and the y shift is over here. So let's insert the values. This is the length of RS, and these are the x shift and the y shift of RS. So let's remove the root from both sides and expand the squares by using the formula that I'm again for the 1000th time showing on the screen. Oh boy, this is a monster of an equation. How do we solve that? Oh my god, is this correct? What? Wait, for this one I need to zoom in. For the first time I have zoomed this much. Let's divide this by 2, so our a is going to be 7 minus 2b, and we substitute a over here, and then we pull everything on this side. Oh my god, this is one hell of a math. Oh well guys, I figured out that there is going to be a b here, so yeah, let's just do this entire thing all over again. This took me a while to realize, by the way. It's dangerous. B here, B here, B here, B over here. So let's do this all over again. Okay, so let's divide all of the terms by 5. Okay, that is just easy. So b is equal to 5 and b is equal to 3, and wait, why did, okay, whatever. Then we find the values of a. So a is equal to 1 when b is equal to 3, and a is equal to minus 3 when b is equal to 5. And that is our final answer. This took an unhealthy amount of time. Oh my god. What the heck is Cambridge on, bro? Oh my god. Okay, what do we have here? Given that, whoa, this looks disgusting AF. Okay, so my first instinct is to replace log 5x with a variable, but we have an x squared over here, and by the formula that I'm showing on the screen, we can pull the 2 from here and over on the normal region. Oh, here is log x5. Okay, so we have to use another formula that I am showing on the screen. This is what I like to call the reciprocal logarithm formula, because it changes the base. So essentially what I did over here is that we never want to have x on the base of the logarithm. We always want to bring x over here and bring the numerical value over here. So we just uno reverse it. But now let's replace log base 5 of x with a variable like our dear a. We multiply everything with a. So from here we get that a is equal to 3 and a is equal to minus 1, and we put the value of a, that is log base 5 of x is equal to 3, or x is equal to 5 cubed, that is x is equal to 125, and then we substitute the value of a over here, that is log base 5 of x is equal to minus 1, and x is equal to 5 to the power minus 1, and that is 1 over 5. So our two values of x's are x equal to 1 over 5 and x is equal to 125. Okay, next question. Whoa, what is this? What are these questions today? Oh my god. Okay, so I see a plus over here and a plus over here, so let's use this formula to break down the pluses into multiplication form. Now I want to write 2 to the 3x as 8 to the x, because when we have stuff like this, we can write it like this, and that is just 8 to the x. Okay? So Now we can replace 8 to the x with a variable. I like to replace stuff with variables, man. I'm obsessed with it. Okay, now we're gonna use, what can we use? We can use p here. Okay. Whoa, we have a quadratic equation. Let's divide everything with 16. That is so clean, oh my god. Okay, now I take my words back. These are pretty good problems. So p is equal to 4, p is equal to minus 1. Now what is p? P is 8 to the x is equal to 4. Now what do we do? This is our base, this is our exponent. We take the log base 8 here and the log base 8 over here. So the x comes over here on the normal region, and the log 8 is just 1, so we don't have to write it. So log 8 4, that is one answer. And 8 to the x can never be minus 1. Why? Because the result of an exponential equation can never be minus 1. That is just the rule. Okay, so that is our final answer. Okay. Whoa, what is this? A curve has equation y equal to this, where a is a positive. The area of the region enclosed by the curve and the x-axis is this. Okay, so suppose this is a curve like this. Okay, so suppose we have a graph, and this is how it looks. It says that the area that the graph encloses with the x-axis is 9 over 16. So we have to find the value of a. Okay, so let's first integrate this equation, and the area is 9 over 16, so let's equate that. Oh my god, I have no idea how to solve this.
2,000 years later.
Okay, I just realized something, that we can factorize y. Like, first we have to find when y is equal to 0, then we factorize this like this. Yo, this was a real good question, like a real good one. And that means, so this essentially tells us that this point is a and this point is 2a, and our y-axis is somewhere over there. Well, we don't have to think about the y-axis now. So bringing this back, this is going to be from a to 2a, and that is going to be 9 over 16. So from here, we can get the value of a by substituting 2a over here and a over here by placing the limits. Let's simplify this. 1 over 6 a cubed is equal to 9 over 16, and a is equal to 3 over 2. And that is our final answer. Oh my freaking goodness. That, if you could do that by your own, you are a math genius. Like, oh my god, this was insane. Okay, final question. What is this? Find the coordinates of the points of intersection of these circles. Wow, an 8 marker. So the first equation is this, and the second equation is this. Now, wait a minute, I see something sus. There is minus 20 and positive 20 over here. What can that mean? Should we subtract these? Let's subtract. Okay, I'm gonna call this equation 1, and I'm gonna call this equation 2. Let's subtract 2 from 1. This x squared and x squared cancel out, and this 2x and this minus 2x, this minus 2x becomes plus 12x, and the y squared and the y squared cancel, and minus 4y over here, and this minus 6y becomes positive 6y, and this positive 20 becomes minus 20, and that is just equal to 0. So, oh, we have a linear equation. Very nice. Minus 14x, or y is equal to 20 minus 7x. Now let's substitute y over on this equation. Okay, this is just an absolute mess, so I'm gonna rewrite this. Well, let's divide everything by 50. Oh my god, finally we got it. Okay, that is just some quick factorization, and x minus 3 equal to 0, so x is equal to 3, and x minus 2 is equal to 0, so x is equal to 2. And let's put the values of x's over here, and so we have got our answers. Oh my god, I'm so happy. Our answers are x is equal to 2, y is equal to 6, x is equal to 3, and y is equal to minus 1. And that is our final answer of this entire paper. Oh my god, bro. I need rest now. Okay, bye bye. Have a nice day. Peace.